Math 3 students, and welcome to your 4.2 Part 2 Ed Puzzle. So I'm going to do a couple of problems from the ready to help you out, all right? So for number 1, it says find the zeros of each polynomial. All right, and we did do this previously where we had to find the zeros of polynomials. So basically the first step of finding a zero is making sure that you're in factored form. Unfortunately, they kind of made our lives nice and easy here, and it's already in factored form. So what you have to do to find the zeros is you take each of these factors and set them equal to 0 and solve. So we would do x plus 4 equals 0, x minus 2 equals 0, and x minus 7 equals 0. Then we just solve. We get x equals negative 4, x equals 2, and x equals 7. So the zeros of number 1 would be negative 4, 2, and 7. All right, so to reiterate, the zeros of the polynomial, to find those, you're going to get it into factored form and set each of the factors equal to 0. In case you forgot, and I'm just going to kind of do a rough graph here. If we were to draw kind of a rough graph of number 1 here, we know that its zeros are at negative 4, 2, and 7. So we've got negative 4, 2, 3, 4, 5, 6, 7, 2, and 7. So that tells you that this polynomial is going to look something like this. All right? And it's going to go through the x-axis at negative 4, 2, and 7. And that's what those values mean. All right, so for the rest of these, you need to make sure that you set each of these factors equal to 0 and solve. Keep in mind, hint, hint, you can have imaginary zeros. All right. All right, so now it says find the domain of each of the rational functions. So what does that mean? Well, the domain is the values you are allowed to plug into the function. Now, one big rule, pretty much there's kind of two things. When someone's asking you for the domain of a function, there's two things you need to look for. You need to look for imaginary numbers. So basically, I guess I should just say negatives inside of radicals. And then the really big one is zeros in the denominator. All right. We know that in math, we cannot divide by 0, right? So if we end up with the denominator equaling 0, we're going to end up with 1 over 0 here, which is bad. That's undefined, and we don't want that in math, all right? So when we're trying to figure out the domain of something, what we need to do is we need to figure out, well, what values are going to make this equal to 0? All right, so let's go ahead. We're going to do it the exact same way that we found the zeros in problem 1. We're going to set each of these factors equal to 0. So we get x equals negative 4, x equals 2, and x equals 7. All right. So that tells you that when you plug in any of these values, you're going to get a 0 in the denominator. Let's test that out. Let's test this theory out. So we would end up with 1 over, and let's try this first one. We put in a negative 4. We get negative 4 plus 4 times negative 4 minus 2 times negative 4 minus 7. All right, so we end up with 1 over 0 times negative 6 times negative 11, which you're going to end up with 1 over 0. And any of these values are going to give you a 0 in the denominator. So that tells you that these values are actually bad. So if you're trying to give me the domain, it would be that x cannot equal negative 4, 2, and 7. So that actually would be your answer there, even though we have x equals. Well, these are the values that x cannot equal if we're talking about the domain of this function. All right. Then lastly, let's go. Oh, and I guess just to kind of go back to this, for all of these, you need to figure out what values are going to make these denominators 0. All right, and kind of restrict their domains. Now let's go ahead and check out the go. So this is going to be a throwback to our polynomial unit. All right. So it says, use the given root to find the remaining roots. Write the function in factored form. All right. So let's go ahead. They gave us the root of x equals -1. So if the root is x equals -1, that means that a factor is going to be x plus 1. Remember, you have to change the sign. So then we're going to go ahead and do our division. Hopefully this brings back some memories. Hopefully not terrible ones. So we'll do 3 minus x squared minus 17x minus 15. So we'll go ahead. X cubed divided by x gives us x squared. Then we're going to multiply this x squared with the x plus 1, which is going to give us x cubed plus x squared. And then remember, we always have to change the sign. So we're going to change this to a negative and change this to a negative. These guys cancel and we get negative 2x squared. And we will bring down our 17x. So now we're going to do negative 2x squared divided by x, which is going to give us a minus 2x. So let's go ahead and multiply. We get negative 2x squared minus 2x. Switch our signs, plus plus, cancel. And we end up with a negative 15x. Bring down our negative 15. We're going to do negative 15x divided by x gives us a minus 15. So we get negative 15x minus 15, switch our signs, and of course, that tells us we did our division correctly because if it's a factor, we should not have a remainder. All right, so now we've got this guy. I know it looks scary, but it's actually not too bad. All we got to do is factor this. All right, so I know we're kind of, unfortunately, I'm running out of space, so I'd imagine you're probably running out of space too. I have the luxury of making my font smaller. I apologize. If you do run out of space, feel free to use notebook paper. But basically, we need to factor this now, right? So if we have x squared minus 2x minus 15, we need to figure out what multiplies to give us a negative 15 and adds to give us a negative 2. All right. In this case, we're going to want to do x minus 5, x plus 3. All right. And then we're trying to find the roots, aka, remember how the roots and the zeros mean the same thing? So then we can set these equal to 0. We get x equals 5 and x equals negative 3. So our other roots here are going to be x equals 5 and x equals negative 3. All right. If you wanted to write this in factored form, all right, it would be f of x equals x plus 1 times x minus 5 times x plus 3. If you're really bored and you wanted to, show that this guy was equal to this guy, you could go ahead and FOIL and multiply and distribute and have a fun time. All right.